Lab number 2 will be complicated. It will have a lot of configuration and devices, but I hope you will enjoy it. In the topology, I'm planning for multiple connections, maybe 2, 3, up to 4 connections per each device, per each router. Routers available here are annoying to achieve 4 up to 6 interfaces per each router. So just like static route, we will use the multi-layer switch because it's more than enough in such cases and such scenarios. I will use 4 devices of 3560, and I will need to make some storms, okay, like broadcast stall by making the need for the DR after that. Okay, come to here please. So this one, make it this way, 2, this one will be interconnected between them just for challenging. How many computers? 2, of course, will be enough. 1 for me and 1 for you. The connections will be this way. These 4 will be connected together, and I will make them function as half routers, half switches, not entirely routers. You will see now. Or entirely routers, maybe I think it will be called an entire router, because now I'm connecting them to switch for redundancy and for making troubles. After that, this is my router and this is yours. Some fast forward. Voila, check spanning tree. What's happening? What's doing? Okay, come to here, come to me. Go up. Go up. Fast interfaces should be clear a bit. This is called multi-layer switch 0. Just let's call it maybe device 1. Device 1. Call it device 1, no problem. Okay. This one should be called. You are annoying. Okay. Switch 1. There is no other switch. This one should be called, please, device 2. Device 3. Device 4. Leave these as PC0 and 1s. Hope all of this is clear to you. You will build it yourself, so you will understand the naming of the interfaces. Now, for this is a switched network, so no IP addresses will be here because this is a layer 2 switch. Okay, we'll leave this. All of these interfaces will be left unconfigured at the normal status with this switch. I will not touch this switch, just make it here to make some broadcast problems. Each router now, this router has 2 routing links, this one also has 2 routing links, this one has 3 routing links, and this one has 3 routing links. Okay, so we will start with my PC. Let's first just type the networks. Let's make it starting by maybe 10.10.1.0/24 and 10.10.2.0/24. These are for the computers. Between the routers, I will have 1, 2, 3, 4 networks only. So I will make them 10.10.10.0/point-to-point, 10.10.20.0/point-to-point, 10.10.30.0/point-to-point, and finally 10.10.10.40 /point-to-point. Okay, so this is for the first PC network. For the second PC network, between device 1 and 2, between device 2 and 4, no, this is device 1, this is device 2. Okay, make it in here. Good. This one, make it in here. This one, make it here. Okay, the 30 for this area, for this one, the 40 for this network, all of them under process ID number 1, Ospf number 1, and all of them under area 0. Okay, because this is the new course requirement. No, please, thank you, that's it. Okay, so let's start the initial config. Desktop. My first PC will be 10.10.1. Maybe it's because the PC, I'll make it .10. This is a class A by default, but I will make it /24, and I will get it back to the gateway of .1.1 on the router. This is not a router, I will make it a router. I hope you have seen the lab, the big lab for static, so you know how we will turn the, whenever you see it, how we will make this switch becomes a router. So enable, configure terminal, please IP routing, never forget about it. Now routing is up. Start to configure the 3 interfaces. Interface fast Ethernet 0, 1, 2, 3. There is no 0, 0 in here. 0, 1 is this one. 0, 2 is this one. 0, 3 is with the switch. 0, 4 is with the computer, with the PC. So 0, 1, I'm sorry, I think you have noticed it before me. 0, 1 is heading to the other device. I will make it first no switch port. Good, now it's a routing interface. IP address would be 10.10.10.1 with /30. Interface fast Ethernet 0/2 heading to the down device, which is device 4. No switch port, please. And the IP address will be 10.10.30.1/30. Fast Ethernet 03 is heading to a switch. I'm not planning to touch this, leave it. Fast Ethernet 04 is heading to a computer. I will make it a routing interface. No switch port. And let's make it 10. The gateway, which is 10.10.1.1, but please /24. I have done with the initial config of this device. The other one has only 2 interfaces, 2 routing interfaces. No, enable, configure terminal, IP routing. Okay, my bad. Interface fast Ethernet, I have 01 and 02 only, so the fast Ethernet 01, no switch port. IP add 10.10.10.2/30. It's this one. Okay. Fast Ethernet 02 is heading to device 3, which is this one. Fast Ethernet 02. Of course, no switch port. And 10.10.20. Let's make it .2 also, because this one is .2, .2, .1, .1, .1, .1, .2. Okay, I will type it just once I finish. Okay, so let's have the IP address of .20.2 and /30. I'm done. Goodbye. Okay, for this device, we have 3 interfaces to configure. One of them will be the gateway to my PC. Enable, configure terminal, IP routing. Okay, so interface fast Ethernet, I have 0. Come here. Yes. Okay, come on. Yes, thank you. Okay, fast Ethernet 01 is heading to this device, 02 is heading to the other device, 03 is useless because I'm not configuring it. It's not useless, it's useful, but I'm not configuring it. And 04 is going to the computer, so fast Ethernet 01, no switch port. IP address will be 10.10.20.1. I'll just make that 1.2, and it's /30. fast Ethernet 02 is going down, so I will make it no switch port, and it will be .40.1. It's this one. Okay, the mouse is clear for you. Okay, the final one will be .4 because .3 is going to the switch. So no switch port, and it will be .2.1. This will represent the gateway for this computer, but /24. So we will avoid any troubles. Get out, come to this computer because we are on this device. Give it an IP address of 10.10.2.10/24, 10.10.2.1, the gateway because it's the interface of the router. Device 4 is the final one to config for the initial configuration. No. Enable conf enable. I remember my teacher was saying enable. Okay, so he was joking. Okay, so IP routing, interface fast Ethernet 0102 only because 03 is heading to the switch, 01 is heading to this device of subnet 10.10.40. So fast Ethernet 01. You might have got headache so far. I hope you have some tea. I don't have some tea. Okay, no switch port. IP add 10.10.40.2/30. Fast Ethernet 02. No switch port, sir. This one will be .30.2. So let's make it .30.2. And finally, I am graduated. Oh god, a lot of config. All of this, 12 minutes. All of this is just the initial config. Ospf will be simple, just don't worry. It's only some things to apply and go. It will not give you any headache. Okay, we will start with the first one. Okay, so configure terminal, all of them under process ID 1, all of them under area 0, so no conflict. Router Ospf 1. Whom am I connected to as a router? I'm connected to this network, and this network. Just advertise them. So network, the first one, which will be 3.10.0, and this is how you type /30 with area 0, enter, and then network. The other one is to the other device 10.10.30.0. This is how you type /30 area 0. The final one should be 10.10.1.0 for the computer. This is how you type /24 area 0. I'm sorry, why you like to miss everything? It was very... Anyway, okay, and I'm done. That's it. That's all I need. This one has only 2 arms, 2 network. So router Ospf 1. The first network should be 10.10.10.0. This way. The other one should be 10.10.20.0 in this way. Thank you, bye bye. Yes, I have adjacency between these two now. Okay, jump to this one. Let's make the PC the last one. After Ospf 1 network, I have 2 networks here, which will be the .30 area 0 and .40 area 0. I will type end and expect a message. I'm sorry, between D1 and D4, D2 and D4. 1, 2, 3. Yes. Thank you. Finally, this device that will logs everything. Configure terminal. Router Ospf 1. The network is 3 networks. 10.10.20.0 area 0. The other one will be .40.0 in this method, and finally the PC network in this way. Hope my keyboard mechanical typing is not annoying for you. In case it was, just inform me. This is the first message for me to have an adjacency with this network, another message to have an adjacency with this network. So now I can consider myself fully adjacent with everyone. let's see if this computer will be able to ping the remote computer. This is not the biggest deal, but how will it ping it through? Which one will it ping? Let's use trace route after pinging. If pinging gets successful, 10.10.2.10. The first one, of course, is a sacrifice. Thank you, thank you, thank you again, thank you all, thanks the audience. And trace, it's trace route 10.10.2.10. invalid command. I think it was trace RT, just like normal computers, so .2.10. So the first stop in this, the first station to stop was 10.10.1.1. This is my gateway. The second one is 310.2, which is this one. This is 310.1 and 310.2 in here. After that, it was 310.40, no, 10.10.41. 41. Oh yes, it is this one, because this is .40, this is .40, and this is why it's stopping in here instead of here. We will see. It should be .20, and after that it's heading to the IP address of the computer, which is this way. So it's heading this way, this way, this way, and this way. Okay, all of the cost is good, but let's just check show IP route, and let's check the show IP neighbors, Ospf neighbor, to see the DR and the BDR. Of course, there is an election happened in the first 240 seconds, the first 80 seconds between all the routers for the DR and BDR to be elected. So for you, show IP route, let's check the mess. This says that it's directly connected to three things. 1, 2, 3. We know this because you have 3, 1, 2, 3 direct connections of routing, but there are 3 OSPF networks that it can reach. The first OSPF is 10.10.2, which is the remote PC. Okay, so the metric is .3. Then 3. It's heading first thing from fast Ethernet 01, so it's this one. This is how we have seen it, and it can also go from fast Ethernet 02 from this way, maybe this way, or from this way and up and down again and up, because all of these paths are working normally. We have no problem with the paths. Again, it can use OSPF to reach 10.10.20, which is this network in here between these two devices. You can going to them, the closest path is fast 01. Of course, it will not go to this network and to .20. It will go to this network first. After that, .20 will be here, and finally .40, which is this one. I believe should go through fast Ethernet 02, and yes, it's through fast Ethernet 02. This is the first command to verify. The other one will be show IP OSPF neighbor. Okay, let's just extend a bit. I need to see good results. So I have only 2 OSPF neighbors, 10.10.20.2. I am full with it. Okay, and I can see that it's the BDR. Okay, and I am full with the other one, which is D4, and I can see that it's the BDR. Then who is the DR? Could it be you? Let's see what the other one have to say about this. Show IP OSPF neighbor. Yes, no, it's .30. 10.10.30.1. Which one of you is 10.10.30.1? Yes, it's this one. I can see that it's the DR. Okay, this one is the DR. Good. This has been chosen as the DR from you, and all the others are BDRs. I think we have there should be some DR other in here. Let's check you. Show IP Ospf neighbor. Yes, the 30 is the DR, the 40 is the BDR, and finally show IP Ospf neighbor 20.2 is a DR, and .40.2 is a DR. I think pack tracer is having a problem here because there is no two DRs. It's impossible to have two DRs. Okay, so having both of them as DRs is mistaking. So you have two neighbors with .20 and .40, and you are suggesting that both of them are DRs. This is a mistake. Okay, no problem. Let's see if there is any other command to configure this. This is the behavior of pack tracer. Okay, show IP Ospf. One. Okay, this is my ID. I am in area 0 only. Number of interfaces 3. No specific information about who should be the DR. I'm thinking that if I disabled these interfaces and made these connects only using the switch, this will make the election takes a real good process. Yes, it will. Disabling these, do it by yourself. I suggest to do it by yourself and inform me back about it. Okay, so disable all of these just like they do not exist and check what will happen using the switch. But then there will have problem about neighbor adjacency advertisement. Okay, let's add it later as a challenge lab. For now, we have used all these complicated things. We have used 4 devices, 4 routers. They are multi-layer switches. We made some of these their interfaces as routing interfaces. Other interfaces were kept to behave as switching interfaces. In the end, we have seen in the routing table how many routes we can reach of Ospf. 6 routes totally, 3 directly connected and 3 using Ospf. This one hasn't been shown totally under any command. These interfaces, fast Ethernet 03 and all these haven't been shown at all, proving that switches are layer 2 technologies and they will never participate when verifying the layer 3 protocols and the layer 3 technologies. Okay, so all of this is to configure this lab. I hope all of this was informative for you. Please practice it by yourself. Just comment below in the video for any concern or observation about it, and we will discuss it and work it again together. Okay, thank you for watching, and we will see you. This is the end of chapter 3, by the way. That's it. It's only about routing, starting on Ospf. We are done in here. The final subchapter was the components of the the components of the routing table, and I have mentioned the components in the static route video already. This is the legend. This is your default gateway. It's not set or the default route, which is not set, and these are the protocols. I have already talked about this in the previous videos. So this is all the topics to discuss in chapter 3. In the upcoming days, chapter 4 will be uploaded. Chapter 4 will be big. We'll have a lot of labs and a lot of theoretical things to discuss, theoretical topics. It will have, I believe it was to be 8 sub-chapters, and they are rich of information and different technologies. Each one of them is a different technology, not related to the other, but in the end all of them are applied under a normal topology like this one, which contains computers, routers, multi-layer switches, and normal layer 2 switches. Okay, so it will be big joy and fun and implementing labs in chapter 4. Please, you need to finish all the first 3 chapters. Firstly, do it correctly, implement them practice the labs. After that, we will start to jump to chapter 4 to finish the entire image of networking for you. Okay, so thank you so far for watching, and hope to see you well at the upcoming videos. Goodbye.